Now we will talk about R and S configuration. So that is relative configuration. We have learned that this is the one which is, or this arise due to orientation of a substituent around the chiral carbon. So four different substituents are there. We have to assign them certain priority, or we have to give them sequence. That's why this rule for naming configuration, whether it is R or S, is called as sequence rule or priority rule. This is discovered by three scientists, Kahn, Ingold and Prelog. So this is alternatively called as CIP rule or priority rule or sequence rule. So there are certain rules or steps are there. That is what we have to follow in designating whether the particular stereo center is R or S configuration. So very first you identify the stereo center, then assign the priorities to the substituent which are become linked to stereo center. Then higher, how to assign priorities? You have to assign the priority based upon their atomic number. The substituent which will have higher atomic number will have higher priority. And you have to view the molecule from the substituent which is away from the observer. Generally least priority substituent will be there on a vertical line of Fisher projection formula. And then assignment of R or S configuration will be done by giving curve arrow. So curve arrow is drawn from the highest priority substituent to lowest priority substituent. If arrows points out toward clockwise direction, the stereo center will be labeled as R, that is rectus Latin, that is right. If it points out towards anti-clockwise direction, the stereo center will be labeled as S, that is sinister Latin word, its meaning is left. So this is how. You could see here a stereo center which is known to contain four different substituent. We have to assign them priority based upon their atomic number like 1, 2, 3, 4. Now we have to start pointing out arrow from the high priority substituent to 2 and followed by 3 and 4. So it is the one which is in the direction anti-clockwise, so it is S isomer, and here you could see the priority assigned to substituent, and when we have sketched arrow, you could see that it is in a manner clockwise direction, so it is called as R isomer, or we have to call it as R isomer. For example, again hypothetical molecule is there, carbon having four different substituent with priority, and we have to draw the arrow. If it is a clockwise manner, R isomer. If it is anti-clockwise, if the arrow is pointing out in anti-clockwise manner, then the isomer will be S. Example of molecule is there. Here carbon which has become linked to chlorine, methyl, hydrogen and ethoxy. So we have to assign the priority to first element which is linked directly to the carbon. So in between these four different elements, you could see this is the order of priorities based upon the atomic number. So chlorine has got 1 among these 4, then oxygen will be 2, carbon will be 3, and then followed by hydrogen which is 4th. So based upon that we have to assign priority, then we have to sketch out, we have to draw the arrow, so it will start from 1, 2, then this, so it is clockwise in the nature, and that's why here configuration of this particular carbon will be R. Similarly you have to decide the priority of substituent around this carbon. Fluorine will be 1, nitrogen will be 2, carbon will be 3, followed by that hydrogen will be 4, and then subsequently you have to find out which isomer it is. Few more examples are there for sake of practice, you can do it on your own.